Welcome back. We're going to wrap up our video series on the heart talking about the conduction and contraction cycle of the heart itself. So how does the heart actually beat? Let's look at our PowerPoint slide, and this is slide number 28. It says the cardiac cycle. Cardiac cycle is just a fancy word for one heartbeat. So it says a cardiac cycle consists of systole and diastole of both atria, rapidly followed by systole and diastole of both ventricles. Systole means contraction. Diastole means relaxation. So what is going to happen is the heart has to have the atria contract and then relax, followed by the ventricles contracting and relaxing. So when the atria contract, relax, ventricles contract, relax, now you have one heartbeat. So that heartbeat is called a cardiac cycle. All right, now during this contraction and relaxation, we have pressure changes within the heart, and that's what pushes the blood. All right, so it says during a cardiac cycle, atria and ventricles alternate their contractions and relax, forcing blood from areas of high pressure to areas of low pressure. Now, one cardiac cycle has some statistics, one heartbeat. So it says at 75 beats per minute, it takes about 0.8 seconds for the heart to undergo one cardiac cycle. So your heart is beating one beat every 0.8 seconds. So that's systole and diastole of the atria, followed by systole and diastole of the ventricles. Now, this is where you're just sitting, listening to this video. It's not where you're running around or exercising. The beats per minute goes way up when we're exercising. Now, there are some vocabulary that we need to kind of know. It says in diastolic volume, or EDV, is the volume in the ventricle at the end of diastole. So the end of diastolic volume. And so when the ventricles relax, they fill with blood. So at the end of that relaxation of diastole, the heart is going to fill with about 130 milliliters of blood. So all this EDV is showing us is how much blood volume can fit into the ventricles when the ventricles fill. Then we have the end systolic volume. So what's going to happen is the ventricles are going to contract and force blood out. So it says the end systolic volume is the blood that's left over after we push some of the blood out. You see, not all of the blood gets pushed out of the ventricles. There's some blood that stays in the ventricles even after we contract them. And that is our ESV, or end systolic volume. After the contraction, there's still about 60 milliliters of blood left in the ventricle. So that leaves us with how much blood we pump. And that's called the stroke volume. The stroke volume is the average amount of blood that's pumped out of the ventricles. All right? And that is around 70 milliliters. So we start with 130 milliliters in the ventricle. We pump about 70 milliliters out. That's our stroke volume. And then what we're left with is our end systolic volume, which is around 60 milliliters. So we are not pumping all of the blood out at once. Now, I do have a handout for this that kind of shows us one cardiac cycle. So I suppose I'll put it on. I don't really emphasize this, but if you look at it, you'll see that it's one heartbeat. So you can see, and I kind of have some things labeled. you can see the actual cardiac cycle where we're going to have the atria contract and relax, and then the ventricles contract and then relax. And what's kind of cool about this is you can see the EKG as well as the movement. So the end diastolic volume is where the ventricles are going to fill. So the ventricles are going to fill here as the atria depolarize. So the atria depolarize, they contract, and we've got our end diastolic volume where the ventricles are going to fill with blood. Down here, after the atria contract, fill the ventricles with blood, then we've got a depolarization of our ventricles, so they're going to contract, and then at the end of ventricular contraction, we have the end systolic volume, which is what is left over after we contract the ventricles. And so there's always a little bit of blood left over, about 60 milliliters. So remember, end diastolic volume is the amount of blood that can fill the heart, which is about 130 milliliters. And then the end systolic volume is how much blood is left over after the ventricles contract. That's about 60. So we're pumping about 70 milliliters of blood. There are moments where we have all of the valves closed or all of the valves open, and this is called isovolumetric relaxation. So isovolumetric relaxation is where all valves are closed just for a moment. So that happens right before the ventricles fill. So the atria are going to contract, the atria are going to relax. So if we just follow this scenario with the atria contracting, the atria relaxing, at that moment we have all the valves closed. All right? That's what we call isovolumetric relaxation. Then we've got further on, when the ventricles contract, we have isovolumetric contraction. It says where the AV valves close right before the semilunar valves open. So there's another instant in our cardiac cycle where all four valves are actually closed. And so these two moments, all four valves are closed during the cardiac cycle. All right, so I wanted to share that with you, and I don't really ask a whole lot of detailed questions about that, but we should know about those vocabulary words. All right, and one last thing here, it says ventricular pressures. So our ventricular pressures says blood pressure in our aorta is around 120, and the blood pressure in our pulmonary trunk coming out of the right side of our heart is only 30. So there's a huge difference, because remember, the thickness of the left side of the heart versus the right side of the heart makes a huge difference on the contraction that the heart can do. However, both sides, the right side and the left side, have the same stroke volume. So they're pumping about this, 70 milliliters on both sides. And it says, why do both stroke volumes need to be the same? Well, this should be obvious to us because we have a closed circulatory system. So this is like a hydraulic system. You have to pump the same amount of blood through the heart to keep everything moving. One of the things that we don't want to have happen is we don't want to have a difference in blood flow from one side of the body to the other, because that'll either cause blood to back up, or it can cause blood to spread out and we can lose blood pressure. So both sides of the heart are going to be pumping the same amount of blood. In other words, they're going to have the same stroke volume. All right, so that kind of wraps up our handout 20C, and we will finish the chapter in class. So I hope you have a good week, and I will see you next week, and we'll wrap this chapter up. All right, have a good one. Take care.